Yeah, I heard.
All right, let me spend some time going over page 4 because there's a lot of polar graphs here. I think polars are the ones that feel most challenging on these reviews. So number 4. Well, first, we know that we have something that's in the form of like a cardioid. The time that it takes to complete the cycle is from 0 to 2 pi. So that makes it easy for us to identify those bounds from 0 to 2 pi, and then 1/2 r squared d theta. So not too much of a challenge there for number 15. 16, we like it when we see just having to find the area of a loop, whether in a pedal or in a cardioid or in a in one of these shapes here, because we know that as soon as we can find a pair of polar zeros, the distance between them is going to be that inner loop. So if we set our polar curve equal to 0, we get pi over 6 and 5 pi over 6, and simply the area between those two polar zeros is the loop that the area of the loop that we're looking for. Uh, 17. Anytime we're looking for common interior, we always want to start off with intersection. That's important for us to build off of the intersection. So the intersections we can find by setting the two equations equal to each other. Sine is equal to cosine when we're in the first and third quadrants, pi over 4 and 5 pi over 4. So when we sketch out the graph here, we see that, remember that anytime you want to find area, you always have to build your area sectors from polar 0. So one way is looking at this graph and see, okay, so from polar 0, I have all these regions that are hitting that 5 minus 3 cosine theta. This is pi over 4. And you can think of this as 5 pi over 4, but it doesn't quite make sense for us to say 5 pi over 4 to pi over 4, because then it's kind of going backwards, and then you're potentially going this direction. So either if you want to go from 5 pi over 4, you can, but then you have to adapt this to be 9 pi over 4. Or another way to think about this, if I was trying to do between fourth and first quadrant of a curve, then I need to make sure that that is continuous. So either I force this 5 pi over 4 to be a negative, so that I can be negative 3 pi over 4 to pi over 4, because then I can go from left to right. I can go from a smaller to a larger value. Or you can go from 5 pi over 4 to 9 pi over 4. But either way, we need to make sure that the bounds are continuous, going in the direction that we care about. And the other one seems a little more straightforward, because from pi over 4 to 5 pi over 4, that's going to clearly hit my 5 minus sine theta. So that feels a little bit easier to see, that 5 pi over 4 to 5 pi over 4. We can see that in our diagram. So then adding up these two regions will give us the common interior that we're looking for. Yeah, but just keep reminding yourself that anytime I want to find area, I'm not just doing top minus bottom, right? We do that for rectangular, but for polar, all our area regions has to build out from the polar 0. So the idea here is if we want to find that shaded region, let's take the circle and let's subtract out the the three petals. And then whatever is left over is that darkened region. So that circle, you don't have to go through integral to get that area of the circle. You can say pi r squared and your r is 4. Or, but if you want, you can just put it into that integral formula that just get you the same one. And then the rose curve, we know these rose curves, if it's an odd n value inside your theta, inside your trig, then you know your cycle is only going to be 1 pi. It's just going to be pi. Versus if it was 2 theta or 4 theta, then it's going to create double the number of petals. So it's going to take twice as long from 0 to 2 pi. So here we can just say from 0 to pi, but the circle is going to be from 0 to 2 pi. All right, let's see if we can spend the next 15 minutes making progress on review worksheet 2. So see how much of pages 5 through 8 we can complete. And tomorrow I'm just going to be checking those 4 pages. I'll be checking. I want to check pages 1 through 8. So hopefully we got through most, if not all, of worksheet 1, and then we can make progress with worksheet 2, and then I can check worksheet 2 tomorrow. But we do need to start our next unit tomorrow. But your test is not until next Tuesday. This week we want to make sure that we have a slot available. So that
What's advanced comp honors? See, but I've never seen that. I think it's kind of long time anyway. Yeah, I don't know. All right.
Yeah, right.
Right. Cool.
For number two, it says find the area, this is on page 5 here. Find the area of that region inside R equals 1 and outside the cardioid. So my strategy here is, I know that this entire region is just a semicircle. So I can start off with that, find the area of that. And then I can just subtract out this portion. If I can find this portion of the cardioid, I can double it to get this portion. And if I can subtract these two out, then what's left over is inside the circle, but outside the cardioid. And then if you use a set of table of values for your cardioid, you should be able to see that you start at theta 0, you start here. At pi over 2, you end up here. So that tells you your bounds for that half loop is from 0 to pi over 2. If I double it, that will give me both these regions that I can subtract out from the semicircles to get that outer region. And then hopefully you're more comfortable finding second derivative in parametric form. UIDX is pretty intuitive, but then when you get to second derivative, just know that you have to find the derivative of your UIDX divided by your x prime. So I think this is the part that feels like it doesn't quite, it doesn't seem as easy to rationalize, but that's needed for your second derivative. Okay, so tomorrow I'm gonna be checking pages 1 through 8. I'll send out a reminder this afternoon. You guys have the key. You guys can pick your answer. Tomorrow we'll start our 10.1, but we can still go back and have a little bit of time at end of class each day to just do more review or answer any questions that you guys have. And I'm gonna save worksheet 3 for help session reviews Monday and Tuesday. So you guys welcome to work on 3 on your own, but I won't check 3 as homework. I'll just save that to go over with you if you want to go over it with me Monday or Tuesday next week. All right, come get your phones.
I'm gonna initially click on stats, but I've already taken this, so I want to ask what the other options are.
Oh, you've already taken stats. Talk to your counselor. As far as what Milton can offer you, there's not anything that really you can take, you know, in this building. Either you don't have a math class or you have to find something virtual or.
Okay.
Yeah, so talk to your counselor.
There's no. I haven't done all of them, but
I'll try to look for some more, textbook I can find. So I'll look for that. We'll try to try to them together.
I know.
awesome, thank you.
Will we ever be getting our, there's a stack, like I know the grades are in the grade book, which.
Yes, students when we just finished taking their quiz. I'll try to get back to you
okay.
Thursday or Friday.
I got it, yeah, that's.
Yeah. Yeah, thanks for asking. Okay.
That's your fault, my. Yeah.
Great, thank you.
I could easily go like this. Yeah, like, AF.
Speaking. And we just, not me at the beginning, but I talked to the person now.
Go ahead.
Yeah.
Guys, anyone in NHS watch me in the picture? Okay, you think you're not wearing your freedoms.
What happened?
See, but I think, you know,
Glad you're right.